So we've seen AI write code, pass exams, even replace some jobs. But here's the big question. Can AI actually do science? The kind of deep, hands-on research that takes humans weeks, sometimes years, to complete? Well, get this. Leopold Aschenbrenner, a former OpenAI employee, predicted that by 2027, AI would become an automated scientist capable of real scientific discovery. And now, OpenAI just quietly released something called PaperBench, a benchmark designed to test if today's AI agents can reproduce cutting-edge research papers from scratch. It's already starting, way earlier than anyone thought. So what exactly is PaperBench? At its core, it's a challenge set. OpenAI selected 20 research papers that were presented as spotlights or orals at the ICML 2024 conference. That's the International Conference on Machine Learning, a top-tier venue. So these aren't old, well-trodden papers. They are contemporary, cutting-edge AI research published just months ago. The papers cover a pretty wide range of topics too. Things like deep reinforcement learning, model robustness, probabilistic methods, the kind of stuff pushing the AI frontier. Now here's the crucial part. The task given to the AI agent, the system being tested, is deceptively simple to state, but incredibly hard to execute. As the paper puts it, agents must replicate these papers, quote, from scratch, including understanding paper contributions, developing a code base, and successfully executing experiments. From scratch. That means no peeking at the original author's code, even if it's publicly available on GitHub. This is where PaperBench gets really interesting, and honestly, kind of intense. How do you objectively grade something this complex? A simple pass/fail is useless. You need nuance. OpenAI's solution was to create incredibly detailed rubrics for each of the 20 papers. And they didn't just whip these up themselves. The paper states these rubrics were co-developed with the authors of each ICML paper for accuracy and realism. That's huge. Getting the original authors involved ensures the grading criteria actually reflect what's important and necessary for a real replication of their specific work. These aren't simple checklists, you guys. The rubrics are described as hierarchically decomposed, meaning a big replication goal is broken down into smaller and smaller subtasks. Okay, so you have the task, you have the hyper-detailed, author-approved rubrics. How does the evaluation actually flow? First, the AI agent runs, trying to produce a complete submission. This submission has to be a self-contained code repository. Crucially, it must include a script named link to reproduce .sh at the root. This script is the entry point. It's supposed to automate the entire process of setting up, running the code, and generating all the results. Once the agent submits its repository, PaperBench moves to the reproduction step. They take the agent's code, copy it to a fresh VM running an Ubuntu 24.04 image with access to an A10 GPU, and then they simply execute that link to reproduce .sh script. This is critical. It ensures the results aren't just hard-coded or dependent on some state left over from the agent's development process. The outputs generated during this run, log files like reproduce link to .log, data files, plots, are what actually get graded. Then comes grading. This is where those 8,316 rubric tasks come into play. Each leaf node falls into one of three types. Code development. Does the source code itself seem to correctly implement a specific requirement? Execution. Did running link to reproduce .sh result in a specific action happening? Result match. Does an output file generated by link to reproduce .sh contain evidence matching a specific result from the original paper? Having these different types allows for partial credit. An agent might write correct-looking code, code development pass, but fail to execute it properly, execution fail. Or execute it but get the wrong numbers, result match fail. The final score for a paper is the weighted proportion of satisfied leaf requirements, propagating up the hierarchy. Now you might be thinking, grading 8,316 items sounds tedious. And you'd be right. OpenAI notes that manually grading even a single submission could take, quote, tens of hours for a human expert. Clearly, that's not going to work if you want to run this benchmark regularly on new models. So they built an LLM-based judge called Simple Judge to automate the grading process. For each leaf node in the rubric, they prompt an LLM with the original paper, the rubric details, the specific requirement, and the relevant files from the agent's executed submission. The LLM then has to decide, pass or fail, 0 or 1. Of course, you can't just trust an AI judge blindly, especially for such a complex task. So OpenAI did another piece of work. They created an auxiliary evaluation called Judge Evil. They took some partial replication attempts, some made from scratch, some by modifying author code, had humans grade them meticulously against the rubrics to create gold labels, and then tested how well different LLM judges could match those human grades. Their best automated judge setup, using OpenAI's own, O3 mini high model with custom scaffolding, achieved an F1 score of 0.83 on Judge Evil. That's pretty solid. Not perfect, but high enough that they felt it was a, reasonable stand-in for a human judge for the main PaperBench results, and vastly cheaper and faster. They estimate the O3 mini judge costs about $66 per paper, compared to potentially thousands for expert human time. Let's get to the main event, the actual results. How did today's frontier AI agents fare on this demanding benchmark? OpenAI tested several models: GPT-4o, O1, O3 Mini, DeepSeek R1, Gemini 2.0 Flash, and Anthropic's Claude 3.5 Sonnet, the new version at the time of their writing. They ran each agent 3 times per paper with a 12-hour time limit per run, using a simple agentic scaffold they call Basic Agent. The headline result? The best performer was Anthropic's Claude 3.5 Sonnet, new, with open-source scaffolding, which achieves an average replication score of 21.0%. Let that sink in. 21%. OpenAI's own O1 high model came in second with 13.2%. The other models tested scored below 10%. So how do we interpret that 21%? On one hand, like the paper says, agents exhibit non-trivial capabilities, getting anything over 20% on average across 20 different, complex, cutting-edge research papers, requiring coding from scratch and running real experiments. That's genuinely impressive in a way. It demonstrates these models aren't just text predictors. They have nascent abilities in scientific reasoning, coding complex systems, and executing experimental workflows. That's a significant step. But let's be real, 21% is not great, right? It means nearly 80% of the required outcomes for a successful replication were not met, on average. Interestingly, the human versus AI graph, figure 3 in the paper, shows the AI, O1, initially outperforming the humans in the very first hour, likely because it can generate code incredibly quickly. But then the AI's score plateaus dramatically, while the human scores continue to climb steadily over the full 48 hours. This really reinforces the idea that current models might be good sprinters at generating initial code, but lack the stamina and strategic depth for the marathon of full research replication and debugging. So stepping back, why is OpenAI building and publishing this? What's the bigger picture? They explicitly state PaperBench can be used as a, measure of model autonomy in OpenAI's preparedness framework. They also reference similar goals in, Anthropic's responsible scaling policy and, Google DeepMind's frontier safety framework. This isn't just about bragging rights or academic curiosity. It's directly tied into the safety and governance efforts at the major AI labs. The ability for an AI to autonomously conduct high-level R&D is seen as a critical capability threshold. If AI can rapidly replicate and potentially improve upon cutting-edge AI techniques, it could dramatically accelerate AI progress for good, like speeding up AI safety research itself, or potentially for ill, if capabilities race ahead of our ability to control them or understand their risks. It opens up so many questions. How quickly will that 21% number climb? What happens when AI can reliably replicate and then potentially innovate on this kind of research? Will it lead to an unprecedented acceleration in science and technology? And are we, as a society, prepared for that acceleration and its consequences? But what do you guys think? Is this PaperBench result, 21% replication success by the best current AI, more impressive than you expected? Or does it confirm that true AI research capability is still a long way off? And how important is it for labs like OpenAI to be building tools like this to measure progress towards these powerful autonomous capabilities? Let me know your perspective down in the comments. It's a fascinating development, and I'm really curious to hear your take. Thanks for watching, and I'll see you in the next one.